Hi guys, Professor Burns here. We're going to take a look at section 7.1. So we're starting our third unit, which is where we're getting into sampling distributions and looking at pulling samples from a population and making inferences about the population based on those samples. So this first section is all about some vocabulary and some symbols that we're going to need to use throughout the rest of the course. So take good notes, make sure your phones are turned off so you're not distracted, and let's get into it. So the first few definitions here, some of these we've actually already talked about, so this is a little bit of a review, but I just want to make sure we remember these because they are important terms. A group of objects or people that we're interested in studying is called the population. So the entire group that we're interested in is our population. A numerical value that characterizes some aspect of the population, this I think is a new term for us, that's called a parameter. So in other words, a measurement on the population. It could be the mean of the population, for example. That would be a parameter. A blank is a survey which measures every member of the population. I think what I was looking for here was census. You may hear us use that term from time to time, but a census is a survey that measures every member of the population. Certainly you've heard of that in terms of the government. We take a census every 10 years where we are interested in trying to gather information from every person in the population. That's not an easy task, but we try to do that every 10 years, and that's called a census. A blank is a collection of objects taken from the population of interest. That would be a sample. So if we pull a subset from the population, that's our sample. And then if we calculate something about that sample, that is called a statistic. So those are the terms we want to be really familiar with. A statistic is any calculation on that sample. It could be the mean of the sample. It could be a proportion from the sample. It could be a variance of the sample. It's sometimes called an estimator. That's another term we may use sometimes. And the numerical results are called estimates, because we're estimating something about the population from that sample. So let's try this example. It says data gathered on the heights of all NBA basketball players. So the key word here is all. I think that's important because when you see the word all, that generally implies that that's your population. The mean of the data is then calculated. So the blank is all NBA basketball players. So the population is the all basketball players that we're interested in studying. And if we calculate the mean height for all of those players, then the parameter is the mean. So in other words, mean height is a measurement on the population. We would call it a parameter. Let's try the next one. A researcher is interested in studying the heights of American women. So she takes a random sample of 1,500 women and finds the mean height for the sample is 63.6 inches. So the 1,500 American women is the sample that she's using, and the blank is the sample of 63.6. So the statistic is a sample mean, rather, of 63.6. So she calculated a mean from the sample. That means it is a statistic because a calculation on the sample. The researcher may estimate that the average American woman is 63.6 inches tall. So she's making an estimate about the population based on the statistic from the sample. So statistical inference is drawing conclusions about a population based on what we observe from the sample. So that's called statistical inference. We're going to use this a lot. And in my opinion, this is perhaps the most important topic we do all semester, because this is really what a lot of research involves, is making inferences. It's really difficult to gather information on an entire population. We usually can't take a census. That's a really, really challenging thing to do. When researchers are testing out a medical intervention or something like how well a new teaching method is working. We can't test it out on everybody in the population. So we take a sample and we test it out on that and then draw an inference for it. That's what we're doing. It involves uncertainty, like I said, because the entire population can't be measured. An important component of statistical inference is limiting that uncertainty. So let's say limiting uncertainty. And there's always a degree of uncertainty. We also want to minimize, let me add this to it, we also want to minimize what we call bias. So all research and survey questions, for example, will have some type of bias, and we want to try to minimize that as much as possible. That's the goal when we conduct sound research. So what are the differences? Again, let's talk a little more about statistics versus parameters. So statistics, remember, come from our sample. So we always know what a statistic is. Statistics are knowable. Anytime we collect data, we can always calculate a statistic because that comes from the sample that we gather. Whereas parameters are typically unknown. We have to estimate parameters using those statistics. So there's always that degree of uncertainty. Now, there are situations where we do know a parameter. An example, go back to this for a moment, the question about the basketball players. If my population is all NBA basketball players, well, the NBA has the heights on record of all of their basketball players, right? So if that's the case, I can calculate the mean height, and I do know what that is because I have information on everybody in that particular population. But a lot of times we don't have information on everybody in the population. It depends on what your population is. If my population is every American, for example, I can't gather information on every American. Like I said, we try with our census, but realistically we can't. So usually parameters are unknown and we have to estimate them with those statistics. Now, some notation that we need to be familiar with. If we're talking about a sample mean, and we've done this before, that would be X bar for the symbol. A sample standard deviation would be S. Sample variance, of course, would be S squared. And then sample proportion. Now, this is a new symbol. I don't think we've used this one yet, and that would be P hat. So in other words, what percentage from my sample, say, agreed with a certain statement in a survey or is going to vote for a politician or whatever. Now, my population mean is going to be mu. My population standard deviation is going to be sigma. My population variance is sigma squared. And then my population proportion, so this is the new one, is just going to be P. So what percentage of my population, say, has red hair? Or what percentage of my population is going to support a certain ballot measure? That is going to be P. And we're going to talk a lot about that in the next couple of chapters. Let's look at another example here. It says the mean GPA of all 5,000 students at Unita College, that's cute, is 2.78. A sample of 50 GPAs from this college has a mean of 2.93. So let's practice some of these terms and symbols. What is the population? So I'm assuming here, and this is a little vague, so depending on how you define the population, this could vary. But I'm going to say the population for this is all students at the college. So all 5,000 students at the college. Then the sample is the 50 that we select. So the 50 that we select for the sample. What value is the parameter? So remember what a parameter is. It's a measurement on the population. Well, the measurement on the population was the mean GPA for all of the students, and that was 2.78. So since it's a mean for a population, I'm going to use this symbol right here, and that would be mu. So mu equals 2.78. The statistic is the measurement for my sample. So my sample mean was the 2.93, and that symbol would be X bar. So X bar is the 2.93. Let's talk a little bit about biases and different types of biases we may see. Now, there's a lot of different types of biases in research, but there's a couple in this class that we really want to focus on. So a survey method is what we call biased if it has a tendency to produce untrue values. If something in the survey is causing the results to be off in some way, that means we have some type of bias. And like I said, there's lots of different types of biases out there in research. So when you take a research methods class down the road, you'll get more into the different types specific to your field. But a couple general ones we're going to focus on. I think my numbers got a little off. The first one I meant to say was, I think it was measurement bias. Let me start with that. So a measurement bias, we'll talk about what that is in just a moment. And then the second type of bias that we're going to discuss is sampling bias. And then the third is to use an estimator that is biased. And so if that estimator we got is biased in some way, it's going to cause our results to be off. But the first two are the ones we're going to focus on. I may throw a couple more in from time to time, but let's just talk about these two for now. What is a measurement bias? So results that come from asking questions that do not produce accurate do not produce accurate responses. So when there's something about the question, usually that's what causes a measurement bias. If we have something in the question that skews people's responses, it guides them towards one response versus another, that's going to create a measurement bias. So usually a source of measurement bias would be so it's issues with the question most of the time. Issues with questions. I would say I really like the term using non-neutral language in a question. A lot of times politicians will do this. They'll send out surveys and they'll ask really pointed questions that are kind of geared to get respondents riled up maybe about an issue or another candidate, and that's a non-neutral question or non-neutral language, and so that usually produces measurement biases. Those are really the main things. So when there's an issue with a question that drives responses in one direction or another, that's what's going to create our measurement bias. On the other hand, a sampling bias occurs when the sample that is used is not representative of the population. So if I pull a sample and maybe I only select women and I'm asking a question that pertains to everybody in the population, or maybe I only select people from a certain age demographic, that means they're not representative, or one area of the country, for example, if my population is the entire country. Things like that would cause a sampling bias. There's some sort of issue with the sampling. A couple of important things to keep in mind. What percentage of people who were asked to participate actually did so? So that could create what's called a voluntary response bias. So that's another type of bias. So how many people that participated actually were asked to participate actually did. Did the researchers choose people to participate, or did they put themselves in the study? That can sometimes create some biases there. And then if at all possible, we want to try to use what's called a simple random sample, or an SRS. So that means we draw subjects at random from the population of interest. It's a random sample. And so that means that every member of the population is equally likely to be chosen. And that's really our goal. If we can get a random sample, that's sort of the best case scenario. It's hard to do that, but a lot of times statisticians have some different methods for sampling that will help them get as close to a simple random sample as possible. All right, so we'll stop there and we'll go over this and practice identifying some of these biases and work on this vocabulary a little bit tomorrow in class. So I'll see you then.